Hello and welcome to this video on reusing water bottles. In some places, tap water is not potable, which requires you drink bottled water. In others, the water tastes unpleasant and filtration is not available. Others again purchase bottled water for convenience. No matter what reason that makes you choose bottled water, it should be different to tap water, right? Unfortunately, no. Many water bottles that you purchase are filled with the same water from the same source that comes out of a tap. If not that, then it is shipped a long distance, or is possibly a mixture of local water and some sort of custom flavor profile. It is for the former reason that many agencies have strongly suggested that bottled water is no better than tap water, that you can and in some cases should reuse water bottles, and that there is a huge caveat to this. In most countries, bottled water is regulated. Whether this is as food or product varies. The focus of this regulation is on the contents of the bottle, but not necessarily the bottle. Packaging is still initially assessed, but as a safe, stable, and single-use product. The types of water that is contained vary from artesian to spring and well water. Although these labels might be on the packaging, they can also be the same water available from the tap. Artesian water is collected from a well that taps an aquifer. Mineral water must come from an underground source and contain at least 250 parts per million of dissolved solids. Well water is very similar to that of artesian water, where it comes from a hole bored into an aquifer. Then, depending on the town or municipality, this could be the same water they use, especially if it is sourced in a large metropolitan center. In all cases, this leads to mostly safe water supplies, or contents of the bottle, with notable exceptions such as Flint, Michigan. It also means that water in the bottle should be interchangeable with tap water. This is where the bottle becomes a problem. Initial testing is on the product's safety. Most retail water is available in a plastic bottle. There are some glass options, but very little else. Plastic bottles are made from a polymer. Polymers are a long chain of repeating molecules. These chains are then cross-linked using a small molecule or part of the polymer chain. The best known of these are your PET bottles, which stands for polyethylene terephthalate. Another option is a high-density plastic bottle. Being a polymer, the structure is prone to damage from heat, but returning to the contents for a moment, the chemical composition of the water can also interrupt these polymer chains. This is why most plastic items will release a small amount of chemical into the beverage or food they contain. An example of this, and a source of some of the controversy around reusable water bottles, comes from an Arizona State University study. They replicated a very high temperature that could be found in cars. Summer can lead to temperatures above 65 degrees Celsius. A water bottle left in those sorts of conditions for 38 days was able to demonstrate levels of antimony that exceeded safe levels. This same process can also release those phthalates. In both cases, it required extreme heat, a long time, and laboratory conditions that were unlikely to be reproduced by the wider public. To make those bottles that you would find in a supermarket petrol station, or other convenience store hard, shiny, and pliable. Manufacturers will add something called bisphenol A, more commonly known by the acronym BPA. It has also received a lot of attention as an endocrine disruptor. This can lead to a number of dysfunctions in the body and later pathologies such as cancer. Fortunately, it has largely been substituted by bisphenol S and other bisphenol compounds. Even if you are looking at BPA, there's unlikely to be much of a problem on first use. That is because the polymer chain has not become depolymerized, and this means there has been no leaching. That changes once you begin exposing it to heat or repeated use, both of which can lead to a breakdown of the polymer chain. Unfortunately, this effect is compounded further by the fact that there is very little evidence that supports the effects of BPA in humans. All of these studies have observed an effect at very high levels in research animals. Regardless, in the future, this may not be a concern as the outrage culture has led to manufacturers moving from BPA and BPS to PET bottles instead. In fact, most beverage bottles in America are made from PET, and the FDA has long since determined that is safe both in single and long-term use. PET bottles are 100% recyclable by comparison to the other options. They can be used repeatedly and are generally not considered single-use. There's also no evidence of an association between what you would find in a PET bottle and BPA or any other kind of known contaminants. There is a final and more pressing concern when it comes to reusing bottles. That is bacterial contamination. Obviously, without proper maintenance and cleaning, the bottle will develop some sort of bacteria from your mouth, the environment, and the contents of the bottle. Therefore, proper maintenance is necessary and removes what is perhaps the most significant and well-evidenced risk to reusing bottles. A final note on refilling your bottle when there is still water in it. The problem is best exemplified by trying to reuse a soft drink bottle. There is always a trace amount of flavor that is gradually diluted out. This creates a dilution that is diluted again and again and again until you no longer taste it. Whereas with a water bottle, the small amount remaining when you refill it only creates a new dilution that can then be added to again because you have not changed the source. This means you are always increasing the contents just a little, very much like compound interest. The same problem applies to bacterial contamination. If you are a consumer looking to make an informed decision, there are safer choices that can be made, and this can be done by looking at the recycling codes, which are most often found on the bottom of the bottle. Generally speaking, those that have a code corresponding with 1, 2, 4, and 5 have no evidence showing there is risk associated with them. This contrasts with those that have a code of 3, 6, or 7. If you follow this advice and take reasonable care not to expose the bottle to heat, damage it, or use it for a protracted time, you should be fine. This is mostly because there is almost no reasonable way for the level of leached chemicals to reach dangerous concentrations. Thank you for watching. If you have found this interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions below.